So today we're going to discuss what is selection sort. So selection sort is a simple comparison-based sorting algorithm that divides the array into two portions, a sorted portion and an unsorted portion. It repeatedly finds the smallest or the largest element from the unsorted portion and swap it with the leftmost elements of the unsorted portion. This process gradually builds the sorted array. So later we're going to see if how this works. So here we have steps. So step 1, start from the first element at index 0, find the smallest element in the rest of the array which is unsorted and swap with current element. So today, here natay array. Sa kaning array na atay elements. We have 64, 25, 12, 22, and 11. So here natay 0, 1, 2, 3, 4 index, which have 5 elements. So first element nato is 64. Then, mangita kaning 64, iyan ning iscan here, iya pangitaon ang pinaka gamay nga elements sa array. So, scan, 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 scan. Kit-ani niya, 11. So, iya i-swap. So, mato si 11 here sa left. Then, ang kaning 11, siya mga pinak-smallest, meaning sorted element na siya. Then, pagkaman, let's, ang kuan na pod, move to the next element at index 1. Kaya naman ta sa 0 na sorted naman ang 0. So, index 1 na pod ta, which is ang 25. Then, ang 25, iyan na sad, pitaon ang smallest unsorted subarray, then iswap na pod sa index 1, sa current element. 25, search. Oy, so 12. Okay. Siya. 12 ang nakabay. Then, search na pod. 22, nope. Then, 62, nope. So, si 12 yun ang pinakagamay. Then, iyan na iswap. 12, iswap niya sa index 1. Then, sorted na. 11, 12, sorted na. Then, index 2 na pod. Sa index 2, nag-swap man si 12 with 25 ganiha, meaning si 25 na nasa index 2. Kaya naman sa index 2 so, ganiha si 12, pero kig-swap raman siya ni 25 which is nasa index 1. So, index 2 na sad si 25. Index 2, mangita na pod siya og minimum sa unsorted subarray, which is ang 22. Siya. Okay, mas gamay pa si 22 kasi ni 25. Iya i-initialize as minimum element. Then, search na po dire, 64 dili. So, balik sa dire, then iya na sad i-swap. So, 25. So, 25 should be naana dire sa index 3, then sa 22 should be naana dire sa index 2. Then, after that, move to the element at index 3. So, meaning si 25 index 3, then find the minimum from unsorted subarray and swap 25 with current element. Kani, pagkita na to, siya naman ang minimum nga element, then iyan sa gihapon i-search nga kung wala na bay lain minimum. Pag ana diri mas dako pa man si 64, so okay, si 25 is the minimum. So, stay na lang siya ara sa index 3 for it will be sorted na ang atong array. So, move to the next element as index 4, find the minimum from a sorted subarray and swap it with the current elements. 64, siya na lang manasa, then stay na siya ara. So, at the end, we got our sorted array na. 11, 12, 22, 25, and 64. Para ma-understand niyo, we have a video here kung giunsa ni siya. But with different elements na, pero the same lagi hapong process. So, na-i-scan. 7, 3, 7 na po si 12 na si 9, then siya, then yun na sa gibalhin, 9, then 12, then 11. So, urat siya. I-scan, ang pinakagamay, then nangita na siya glain, nga pinakagamay, then iya kitawon if kinsay mas dako nila para ang gamay is ngadto sa left. Again, we have 3, there is a left, then 7, we have 9, there gihapon sa left, then we have 9, then 12, ngadto sa left, then 12, kuan sa 11, then ngadto niya sa left, si 11. Then si 12, na nasa last. So here we have the selection sort implementation. So the code, this code is repeatedly finding the minimum element from the unsorted portion and placing it at the beginning. So, ano siya nga code? So, yeah. Today, we're going to break it down. From line 2 to 3, we have void selection sort and array and I. So, meaning nag-initialize sa here o parameters na int array where we here nga rin nato i-store nga to ang mga unsorted elements. And I as the initialization kung ang kadto nga data, ang first data nga rin masulod. So, for n I is equals to 0, I less than n minus 1, I plus plus. The outer loop runs from the index 0 to n minus 2, where we stop at n minus 1, because the last elements will be already in place. Meaning, ang last elements ang pinaka-last, meaning just siya sa iyang place. So, the variable I represents the boundary between sorted and unsorted portion. I is our index. So, find the index of the minimum element in the unsorted portion. So, for int j is equals to I plus 1, add that na to index, then j is less than n. Then, mga dita, if array j is less than array min index, then min index is equals to j, then j plus plus. Min index I assume the first element of unsorted portion is the minimum. So, mo na to sa index 0 first, siya kunuhay first ato ang unsorted minimum. This will store the index of the actual minimum element. Kaya iya pa man i-check. Then, after that, nga rin na, muskan siya to all elements from I plus 1 to the end. So, meaning, iskan niya sa index 0 to the end. Then, whenever it finds an element smaller than the current minimum, it updates the main index. So, I makascan, then update. Kari siya, muna siya. Ano to? Like here. Niscan siya. Here, niscan siya nga siya ang minimum. Siya anay first, correct. Then, scan, then kani minimum, then muscan, then if makita nga gamay, then muna sa tuya initialize as minimum. Muna siya ang siya nga ri. Then, after that, nga ri, iyan na daw i-swap ang minimum element with the first element of the unsorted portion. So, iyan na i-swap sa index, kung asa nga index, o kung asa nga index ang minimum, then iyan na i-swap. So, in temp, where kadtong element inyo i-temporarily store here para dili mawa is equals to r min index, which is ang kani nga ri. And then, r min index is equals to r I. So, iyan na i-swap ang kadtong minimum sa index kung asa na first nag-start. Ang katong atong gipang sana gi ato gi compare kung kinsay dako or gamay. Then, Ri is equal to temp. Meaning, ang kaning value sa Ri, which is ang value sa R min index, which is ang J, kung ari na sa temp. It swap the minimum element found with the element position I. Then, use this temporary variable to avoid losing data during the swap. So, next abroad is nanata sa main function. So the main function, here, this initialize the array and calculate the size. So nga rin na naman tayo, array here na ay 7 elements, which is 64, 34, 35, 12, 22, 11, and 90. So size of array divides size of R0 calculates the number of element. Iyahan na i-calculates is 7 budget. 7 makabuok elements ang naa sa array. Then, here, iya na i-print ang original array, which is 64, 34, 25, 12, 22 ka na. Iya na i-print. Then, ang selection Rn calls the sorting function which is kani, yan ang i-call, para i-sort na ang kani. Then, iya i-print ang sorted na array, which is mungari, then mungari, then mungari na. Then, return to 0. So, ang execution, for example, mo find tag minimum array. So, na ay, first is kani, mo gyapon ni atong current, the index 0. No, scan ta. Scan, mas gamay pa ni? Yes. Scan na pod, mas gamay pa man ni? Yes. Scan na pod, mas gamay pa man ni? Yes. Scan na pod, gamay pa man ni? So, 12, 22, yes. Oh, no. Then, scan na pod if dako ba si 22 o 11? Yes. Mga rin na pod, 64, scan ba? 90. Yes. So, 90, dako man. So, nga dito sa 11. Then, kaning 11, iya na i-swap ari. So, si 11 should be here na, then 64 should be here. So, it should be 11, 12, 25, 34, 22, 64, 90. Then, after that, mo is dog na sadta diri mo search na sadta og lain minimum. So, for example, is 11 naman, nga dili dako man, dako sad kani minimum. Napod, 12. 12, imo i-swap sa 34. Kay mas minimum naman ni siya. 12 na siya sa index 1. Then, after that, find the sad og minimum, which is ang 22. Then, i-swap na pod siya sa 25. Then, after that, ang iyahang complexity is O n to the power of 2 because of the nested loop. Iya pa man i-scan, i-sort, i-tap, scan, i-sort, i-tap. So, ang sorted array in this one should be 11, 12, 22, 25, 34, 64, and 90. So here, time complexity of selection sort is 0 to n squared, where n is the number of elements in the array. This is because each element, each iteration, it needs to find the minimum or maximum element from the unsorted portion. Selection sort is not the most efficient sorting algorithm for large dataset, but it is simpler than more advanced sorting algorithm, which means nice siya, but if large na ang data, mas dako iyahang time. So kung daghag data, taas og time need. Kay iya pa man i-scan ang datas kung kinsa pay mas gamay. Mo una siya dako, then pahitaw ng gamay, then i-scan pa ang rest, then usa pa niya ibalhin. So, similar to bubble sort and insertion sort, selection sort is not recommended for large data set due to its performance characteristics. However, it can still be used in situations where simplicity is more important than the performance. The difference and best and worst case for selection sort is mainly the number of swaps. So, in the best case scenario, selection sort does not have to swap any of the value because the array is already sorted. Muna ang best case. And in the worst case scenario, where the array already sorted, but in the wrong order. So selection sort must do as many swap as there are values in array. Kaya sige lagi siya og swap. Iya pa is-search ang minimum. Iya pa is-scan tanan elements sa array, value sa array, usa siya mo swap. Kaya iya pa man i-check if mauna ba jud ang minimum nga value. So conclusion, selection sort is a straightforward sorting algorithm that repeatedly selects the minimum or maximum element from the unsorted portion and places it in the sorted portion. While it's not the most efficient sorting algorithm for large datasets, it can be useful for educational purposes and situations where simplicity is valued. So selection sort is pang small data sets lang siya. Thank you.